Welcome everyone. This is our hands-on workshop. Our topic is create an end-to-end pipeline in CloudFormation, presented by Rachel Hu. As usual, a link will be placed in chat, and feel free to leave questions there, and we will address them in Q&A sessions. And since it's a hands-on workshop, so when you're working on in the process, there may be some technical issues that you may encounter. Feel free to drop the questions in the chat box, and we will try our best to assist you. Give a one round of applause and welcome Rachel. I'll pass the control to her now. Thank you.
Thanks. Let me try. Can you hear me?
Yes.
Let me say. Let me share my screen. Can everyone see my screen? I'm not sure what you are seeing.
Yes, we can.
Yeah.
Yes. Awesome. So thanks everyone for inviting me to this workshop. So this is Rachel, and I'm currently an applied scientist at Amazon Machine Learning University, which is a team belongs to AWS, Amazon Web Service. So today I'm going to have an introduction for this end-to-end machine learning productization pipeline. So those slides I stole from our lectures in MLU, Machine Learning Universities. So the original lecture was 3 hours, and today I tried to squeeze it in 1 hour. So probably sounds a little bit rush, but feel free to kind of interrupt if you have some questions. And I try to kind of omit those peripheral contents and focus more on the high level end-to-end machine learning pipeline in this 1 hour workshop. So let's get started. Here's kind of schedules for today. For the first 15 minutes, we're going to have an overview or introduction of how does an end-to-end machine learning lifecycle look like. Whether we need to, where do we get the data, as how do we deploy the models and monitor it in the end. So that will take about 15 minutes. And then we're going to build an end-to-end machine learning system. It's kind of toy system, super simple, but you can always reuse for your specific use case. That will be in lab, and it will take about 30 minutes. And I will also leave the last 15 minutes for Q&A. So with that, let's get started with machine learning lifecycle. So for ML productizations, it sounds like a weird name, but it's really a kind of iterative process. So before we're kind of starting building a machine learning system, before directly diving into building the model, like what I used to be like 5 years ago. So we need to already answer some critical questions that includes some system requirements, constraints like the cost or some success metrics for the model or the system, etc. And in this case, we're trying to go through this problem formalizations. Oh my God, I got something pop up. And which means that we try to formalize a given problem, a real life problem with machine learning language into a machine learning procedure. So after problem formalizations, we're moving on as like the data engineering. So once we made the business decision, we need to go to solve this business question using machine learning, then we need to collect some data, aggregate the data, probably clean it, massage it, store it somewhere. So that's data engineering. And moving forward, after we have enough legitimate data to train, we can though start with the training and evaluation. And notice that when we're training the models, almost most of the times, it's a kind of iterative. So we need to kind of decide, does this model meet our goals per our defined matrix? If not, we probably need to go back and retrain it to try to achieve the goals in terms of no matter model performance, like accuracy, precisions, or like the model throughput, or some kind of latency requirement. So that's training and evaluation. So once the model is ready, what we need to moving forward is deployment. So we either deploy the model into a dev environment, which is for maybe QA purpose, or like production environment. So we'll see more details in the lab. And so after you deploy model, you think, oh, everything's good. Everything's good. So my job finished, but actually it's not. So after the deployment, what we usually do next is we're going to monitor and maintain the machine learning system to ensure there's like a kind of successful end-to-end machine learning production solutions. And that is how we ops or operations are involving here to go back and iterate it to see how we can improve this overall system. So this is just one pass of machine learning lifecycle. We always like go back and while we are building this overall machine learning lifecycle, always remember that we're not kind of only focused on the technical aspect for like the model performance or system performance, but we also need to kind of realize first that like, is this model fair enough towards some individual groups? And we're trying to avoid some biases to that. There are a lot of these cases which got like a lot of this societal issues. And two, also be reminded that we need to protect the private personal information from our customers. Like Amazon always said, customer obsession, right? And third is everyone needs to understand the result not only by our science or engineering teams, but also by our customers, our users. What does it mean for the sport, right? And last but not least, security and free of vulnerabilities is also of high requirement of a machine learning lifecycle. So that's an end-to-end overview. It probably a little bit kind of abstract for you, it's pretty theoretical. So let me walk you through each of the components of a machine learning pipeline with this simple visual search system. So suppose you're going to build like this mini Amazon Go, which like if anyone go to Amazon Go kind of store, that you just need to grab anything from the grocery stack. But when you go out of the store, you do not need to check out. There will be camera knows what kind of things you grab from the shelf. So we're trying to build a really simple kind of tooling model for that Amazon Go system. So the environment setting here is that you have this tiny camera. I think it's not well displayed here, but it's kind of hiding behind the shelf, so you can see what is happening on the shelf. But what is attached to it is like this Raspberry Pi, and this is kind of the local device engines, and that it will process what the cameras got and send it to AWS or the cloud, like Kinesis or SageMakers can digest the data. So here's the environment setting. And our goal is kind of to detect where there are more or less commodities or like, you know, the drinks on this shelf. For example, if someone put like a coffee or soft drinks on the shelf, so the model should be detect with like this stock transactions. As you can see, if someone's putting, let's see, there's some delays here. Let me coming back. Okay. So you can see there will be some stock transaction if someone putting something on the shelf, and there will be a bounding box trying to detect, oh, this is a coffee and this juice, etc. So there probably will be some delays between the real life procedure and what is showing you in the Jupyter notebook here. But this is kind of the toy system we're going to build. So how we're going to build this, and can we use like the machine learning life cycle that we just described, the pipeline just described? So let's take a look. So step one on problem formulations. So here are some questions we're going to think of when we kind of design the system. So first is, what are the inputs and outputs? So the input and outputs probably like the drinks, the noodles, etc. And the output probably like with some bounding box towards like those goods, and there will be some like accuracy measures for that. So that will be the input output. Question one, relatively simple. And question two, what is how to measure this machine learning performance? So there will be a tons of metrics. So for any of you who are familiar with computer vision, one of the metrics can be IOU, or intersection or unit, and definitely will need some like average precision metrics, etc. So I won't talk about a lot of details here, but just brainstorming together. So question three, what are the hardware software requirements? So is it a batch inference or online inference, or we can do both? Is it on-premise inference, cloud-based inference, or we can do both? Or, and of course, like all those like hardware software requirements, which one is more cost efficient, but also can satisfy the latency or system constraints? So that's all the question we need to think about. I just give you some ideas here. And moving forward, it is data engineering. So for data engineering, usually what we start doing is like data ingestion. So it's not really like you go to Kaggle and there's a data already there. For a lot of this industrial problem, what we need to do is we need to scrap the data either from web sourcing, or if you're going to do some reinforcement learning, for example, you probably need to go like do a lot of simulations to simulate different trials and to say how the agents connected through those trials. And or like what we're doing here in this case, what we do is like we manually collecting out this image. So we got like around 100 of those image, and then we use like the Amazon SageMaker ground truth to manually label each image by humans. So it didn't take a lot of time if you have several people on a team to label together, but we quickly get this image, and we then using fine tuning later. So that's like the data ingestion and then data processing. Like I mentioned, we label this, I'll clean it a little bit, and apply some feature engineering and data augmentation on that. So that's data engineering part. And next, what we're going to do is data ingestion, processing, and transforming this code. So this is kind of the sample code we use for that mini Amazon Go project. So you can obviously more details in this video stream, computer notebooks as in the GitHub there. And so we can take a quick look of this code. So what we're doing first is we first connect the Raspberry Pi with AWS Kinesis. So we can then stream like the video from the Raspberry Pi get from the camera to the cloud. And then we also need to get endpoint data from the URL streams, which retrieve lively from the streaming to the cloud to the SageMakers. And also we need to process the raw data and display the video stream. We can ingest about like 1 frame per time at this time with Kinesis. So you can see, if we can see the screen, there will be some video processing here. And if you cannot, we can return an error. So that is like a fundamental way, how do we ingest the data? And now let's talk about modeling. So modeling sounds like super straightforward for a lot of data science like you are here. So we first decide on how many epochs to train the detectors. And then by calling the training functions, and we start the training process. And finally, we can save the neural network somewhere and reuse it later. So for the training function, we just apply fine-tuning method, and we just grab the model, the pre-trained model from the ground series model too. And that is our ResNet 15 models. And we just apply and just fine-tune over like those 100 image we just labeled. So that's on the modeling part. And moving on for the testing. So since this is a hackathon project, the testing is relatively simple. It's not really the kind of QA testing or productional qualities of testing. So it's like just a sample here. How do we validate the models? So here we define the metric, which we're going to use the MAP or mean average precisions across all of these different class for these different groups. And then we simply using the ground saving model we trained, and with the IOU threshold with 0.5, that's cutting off. So once the prediction and the ground truth are the same class and the IOU is greater than 0.5, we can count the predictions as a true positive. So that's a kind of the testing mechanism. And then we load the training parameters to the same architectures without some weights. And then we set up some like parameters here, like a weight size and batch size. And then we can loop in through the validation data set to load the data and can generate predictions. So that's like the testing file. And moving on, so we deploy that. So most of the code we are deploying are kind of one on SageMaker, and another part is on Raspberry Pi to tell Raspberry Pi what should you do, how do you stream the video to ingest in the SageMakers. So that's kind of the streaming function we just talking about, and also the object detection function. This Pi file we're putting in to kind of ingest and letting the Raspberry know what kind of object are you going to kind of detect there. So all the code are in the Pi file or Jupyter notebook there. So that's it for this kind of sample example to give you a full understanding of the overview of machine learning F cycle. Before we moving to the lab, any questions?
I think it's very clear about each of the steps. Yeah.
Awesome. If that's the case, let's go through the lab. So for the lab, we're going to create an experiment that's end-to-end ML pipeline via CloudFormation. So it's supported by some automated infrastructure for training, testing, and deploying, and also integrate your machine learning models. And furthermore, this pipeline can enable us to deploy in both development environment for QA testing and also production environment. And in addition, if you say in lab 2, we're going to apply some stress testing to check whether our machine learning system is scalable enough, and also is it have high availabilities. So please click through this link, and it will bring you to the MLU lab. So let me try to let me try to reshare my screen with the lab. So screen. Can everyone see my screen about that GitHub?
Yes.
Awesome, thank you. Okay, cool. Let's get started with the lab. So as I just introduced, it will be an end-to-end ML pipeline architectures. So for any of you who don't have AWS account, I would highly recommend you to get one. A lot of like these resources are free within 12 months. Well, if you're like me, I already got this my AWS account like a few years ago, so I won't be eligible for this free tiers. So running this app probably will cost you about $1 if you delay that right away after you successfully launch it. So just some alert here. If you don't have a free account, it will cost you some bucks. So make sure that you delete it or come back to check out your account, your bills after a day to see whether you got everything deleted and your bill is not streaming anymore. So just a learn for the building. And let's first take a look of the architecture we're going to build for today's end-to-end ML pipeline. So here's a full kind of overview. Let me enlarge this a little bit so everyone can see it clearly. We're going to use a lot of AWS service like code pipeline. As you can see, the vertical line here is all involves code pipeline. Basically, it will trying to orchestrate all this like different kind of actions for your machine learning system. So what are we doing here is like, so first, the code pipeline will just have listen to the S3 function on the S3 dataset. So once S3 dataset got a new data file, for example, as an ML developer ourselves, we put a data inside, or if you are going to kind of have some data streaming from a JSON file or from a database, and also there's a data inside. So there will be a learn generate to the code pipeline. So the code pipeline will validate the request or whether this is a legitimate data file that we can produce or we can process through this code pipeline. We're a Lambda function. So the Lambda function will go to validate that, and if it's good, so the code pipeline will then launch the training job. So how do we launch that? So the code pipeline will then call a specific CloudFormation stack called training job, and that will initiate a Lambda function to talk to a SageMaker. Oh, you need to go to train this model where this new data set will just come in. So the training is done. The next step is deploy. So the code pipeline will automatically deploy to the development environment for QA testing. So how does it do the job? So it will call the CloudFormation stack, which is called the deployment to dev stack. And this stack will involve a Lambda function, which names like MLOps deploy. And this deploy Lambda function will directly call the SageMaker endpoint deployment to say, oh, you need to deploy this endpoint to our dev environment. So once everything's good, probably if you are going to do production, you're going to testing a lot of like different functions here or features here. And once everything is good, then as the machine learning developers, you're going to come in and approve that. So the code pipeline will give you a green button and you need to hit approve. And then after that, the code pipeline get your approval will automatically deploy what you just trained into the production environment. And that involves a code CloudFormation stacks that directly call this Lambda function called MLOps deploy. And this will deploy a SageMaker endpoints to productions. And at the same time, we also enable this auto scaling functions. So in case if you suddenly get a lot of traffic to your endpoints, the instance can automatically scale per your throughput for your kind of traffic ask. So that's kind of a high level overview of what I'm going to build today. So let's try to build ourselves. So this lab, as I just mentioned, is used to be like 3 hours. And we are probably only going to cover the lab 0 today. But lab 1 or lab 2 here, they are pretty straightforward. So they are just in the notebook and you just need to follow the notebook to run. And you probably need to, there are some exercises in the notebook, you need to fill the blank in the notebooks. But beyond that, you can just run the notebooks and build the lab. So we are focused on lab 0 today to build an end-to-end pipeline with CloudFormation. So for CloudFormation, for any of you not familiar with it, it's kind of infrastructure automation platform that we can create out the component which can be reusable, testable, and auditable. So the CloudFormations will need some templates. Usually there's some YAML file, and to launch, so they know what are the instructions to launch this ML pipeline. So first, what we need to do in this lab is we're going to download like this MLOps lab zip file. So you just click through it and you should download here and in your folders. And after you download that, we're going to upload that into S3 buckets. So click through that. It will bring you to the S3 buckets. So by the way, I pre-log in to my AWS kind of console. So if you pre-log in, this function should automatically bring you there to your S3 bucket. So here in the S3 bucket, as you can see, we can click the create bucket, and we can, let me just use this side by side. Here. Okay, so here I have my instruction on the right and also my AWS cloud on the left. Let me just enlarge this a little bit so it looks normal. Here we go. One second, let me do it. Okay, so here is it. What are we going to do? Is we're going to create the name of the bucket, which is exactly the same name as what is described here. So we just copy it, but you need to add your own alias. So this alias will be super unique to you because the bucket name should be unique across the globe, no matter which region you're saving. So make sure you have a super unique name. Like what I'm going to do, I'm going to have Rachel 0325. So this is today's date. So remember this alias, and we are going to reuse it a lot of time later. So that will be my bucket names. And we're going to set this bucket in the US West regions, and everything else we're pretty kind of keeping the same here, unchanged, and then you can create the bucket. So once you create the bucket, as you can see, you can click through it. And what we're going to do is upload what we just download from the zip file on the right here. So let me find my folders. The folders I just download. So this is the MLOps lab folders. Let me put it here. So this is the zip file. I just unzip it. And what I'm going to do, I'm going to kind of put everything, upload into my bucket. So that's it. So there will be 11 files in total, and you just need to hit the upload. It should be pretty fast since it's less than 1 megabyte, I remember. So once it's successfully uploaded, so then we're good with S3. And the next step we are going to do is create this CloudFormation stack. So let's first go to CloudFormation by open the link. So let me move to the left-hand side. So here's the main page of CloudFormations, where is that infrastructure as service. So what we need to do is we're going to create that. And similarly, we're going to keep almost everything here, but we need to fill this S3 URL. So how could your CloudFormation on your account fill of the template to create the stacks? So we need to go back to this S3 bucket, navigate to this MLU, MLOps labs CF YAML file. So click through that. It will give you a URL. So there will be an object URL here. We're going to copy that and paste it here in the CloudFormation stack. In this way, we will pull in the CloudFormation. Oh, here is a file that is sitting in my S3 bucket. So you just need to go to grab it, and you can view it. You can also view it in your designers. It will gives you a lot of different architectures. As you can see, we are going to have machine learning workload and some like different code pipeline or Lambda functions, S3 bucket, etc. How like all these different service orchestrate together. They were all orchestrated by this CloudFormation. So that's it. So this is just overview of the file, which is interpret the file we just upload, which is on this YAML file. So let's go back. I remember this is, yeah. So click this button, it will bring you back to the CloudFormation. So you have this URL, and you're going to create a stack by hitting next. So we need a name. So this name can be anything random. I will just create this name, Women in Data Science 0325. So it can be any name. This can be repeated like across like the globe, but it should be unique within your own account's CloudFormation. So find a name, put in here. And for the security group, we're just using the default security group. And for the subnet, we can choose anything here beside this 48. So don't choose this 48 subnet. I think it probably don't have enough instance for that. We always get into trouble. So I'll just choose any subnet beside this 48. So I choose this 0.0. And then we also need to replace this user alias. So remember, we fill some user alias when we are setting up our S3 buckets here. So I filled this Rachel 0325. So you probably have your own unique ones. So let me fill this Rachel 0325 here in my user alias. And that in this way, the CloudFormation will know which are the model they're going to coming back to trace it. So that's the CloudFormation stack and the name. And we're going to keep almost everything as default here and click next. And similarly for this review step, we're going to keep this kind of review, and we're not going to change anything. But we're going to acknowledge what will happen, and then we can create a stack. So as you can see here under your CloudFormation stack, there's a new stack which names Women in Data Science 0325. It's kind of start creating. So you can always kind of click the updates to say what is happening, what is already created, what is not. So this creation probably take like 5 to 10 minutes. We're waiting for it creating there. Any question? Let me open the chat. Yeah, any question, please feel free to yell it out.
Oh, Rachel, so thanks so much for the sharing at first. Yeah, I think it's very easy to follow and use, and we do receive some questions from the Mentimeter. Do you want to answer that? Yeah, I think it's good to answer the questions on Mentimeter because I don't think there's any, like throughout the process, there's not much detailed step that they're missing in the check. So maybe we can start from some other high-level questions. Oh, there's one. Feynman asked about, could you please show the content of .yml file and
Yes.
any specific format?
Yes, great question. That's a great one. So here is a YAML file that we are using to kind of orchestrate like the overall kind of this overall pipeline, as I just showed in this image. So it's pretty complicated. But I think what I can do is I can just give you a high level overview of what is doing there. So as you can see, First, this YAML file. So basically, this will be the input for the CloudFormation we just created. So it asks 3 parameters, which we just input there. So the first parameters is a subnet. So what are subnet we use? So what we use is a default subnet. And second, it's a security group ID. As I just mentioned, we are choosing any security group besides the 48 one, I believe. Let's see. Yeah, we're just choosing anything besides this 48 one for the subnet ID. So this is basically what is this displayed here. And the last parameter is your alias, which is the one I just entered, which is that this Rachel 0325 one is what I just entered. Let me put an example here. And you probably have your own alias that should be unique because your S3 bucket should be unique. So that's it, the 3 parameters. And what it's doing for this overall CloudFormation is going to connect everything into a whole picture. So first, it will call this MLOps security function. Basically, it's kind of a template. So this template, we also upload that to our S3 bucket. So all the templates are kind of here in the zip file we download. As you can see, there's this security alias YAML file. So which it will, I'm trying to make sure it will create a role that this role will be allowed for a different kind of services within AWS. So this is kind of assume a lot of role. So that's like the kind of a substack that our main stack created there. So this is the MLOps securities. Similarly, here's the Lambda layer. So this Lambda layer will go to create a CloudFormation stack, and this stack will based on this template, which names is this CR helper. So let's say what does CR helper do? I think this is the one. So this is a CR helper. So what it's doing is, as you can see, it will call this Lambda function as a helper function, and then it will just building everything from scratch to see how the Lambda function will kind of send the message to kind of orchestrate, to kind of instruct the other machine learning service what to do. So kind of this is kind of a helper function. Similarly, we have this MLOps process request. And this is basically if you have a request coming in and it will process it. And also it is based on this YAML file. Also we upload into S3. And then there is the deployment operator. This function will get triggered when there will be a new deployment job from code pipeline. So it is also kind of a CloudFormation kind of stack. Listen there from code pipeline. So that step should be what we discuss here. For this deployment here. So this is a CloudFormation stack, and it will listen to this code pipeline. So that's the deployment. We also have this training operators, which is just training the model using the SageMaker. So that will involve this step. So this is the kind of this the CloudFormation training job stack as it's shown here, where it will call the Lambda function. Oh, you need to tell the SageMaker to train us. So this is what we have, and this function is kind of a Lambda function here. We're going to set up the environment. And this also environment setup call, and there are the 2 repos that we're kind of building here for code commit and one for the ACR repository. One is to save the models, one to save our code. And also, last but not least, we need to connect the this CloudFormation stack with our S3 bucket, telling him, oh, what are the buckets you need to save? If there's any kind of prediction file or model file, you're going to store everything into S3 buckets called MLOps bucket. So this is kind of overview, and that this is just a pipeline of CloudFormations, how we're going to build that end-to-end models. So let's go back to check.
I think some of them get an error about rollback complete. Do you have any idea what may cause?
Yes, let me say, okay, I think I got created complete. So for anyone who got rollback complete, what you can do is you can go back to the events. There will be something specific told you is a fail rather than created complete. So it should be a fail here somewhere. You can then navigate to more details if there what is a rollback complete error. So when I first started this lab last year, I got like more than 50 times of this rollback complete error. So there are just tons of different errors there. You probably don't have permission to use some of the service. Probably some of the service don't get permission from others. So there are a lot of different errors, but you can always navigate to see the logs. So the good thing of CloudFormation is you can always see the logs through the status, reasons. So if any of you having question, like have a rollback question, you can feel free to post it in the chat and I can try to help you on that. But yeah, when I first started, it's just like tons of error. Am I clear on this YAML file question, or you want me to explore more on that?
Yeah, I think
okay, cool.
It's good. We do have a couple of questions on Mentimeter about other high-level questions that hope you can answer.
Yes, please.
Sure. So the first one is about Amazon Go. So in the case of Amazon Go, how does the model detect if the customer picked something and kept it back? Would it detect the objects again and remove from the transaction?
Yeah, good question. So just to clarify, what we are building is a visual search system. I just using Amazon Go as an example to kind of give you some sample that what can be applied to. But coming back to this Amazon Go question, so what we do, if you have tried Amazon Go, you will see tons of hundreds of cameras all over the place, and they're just tracking you. Like if you're grabbing something, they can catch it. And what they're going to do is like they're going to have a backend system. They're going to process and detect what is it, how many do you grab, and how should I charge you? Like what is the count? So that's why after you kind of get out from this door of Amazon Go, which will take about 5, maybe 10 minutes to kind of process, and you will get the receipt after 5 minutes or 10 minutes after you coming out from the Go store. So that's like the overall process. Basically, we use a lot of like object detection and classification for different goods, and to check whether who are you? Oh, yeah, it also have face detection. So when you're entering the store, you're kind of scanning your code, and they also kind of get your face. So your face is linked to your code, your Amazon account. And then we are hanging out in the store, you kind of grab a water, grab whatever grocery, and then they will attach your face with the food you grab. And then we are getting out, they will process it, and you will get a receipt for whatever thing you grab and what should you pay. So that's like the overall kind of idea. Is that clear?
I think it's loud and clear. And the second question is, can you explain what is the difference between auto-scaling function and the serverless service?
Yeah. Good question. That is the typical solution architect question, I would say, for AWS. I'm not kind of eligible solution architect, but I can give you a high-level overview. So auto-scaling, I would say, is one of the functionalities for serverless. So serverless, what does it mean? It means that we do not need a lot of human to sit there and serve this whole model, right? it can serve itself. That is called service. So service will involve a lot of different features, a lot of different AWS services are service. So the auto scaling is just one of the features of them. For example, like Lambda function, it's really kind of service function. Whenever it listens to something, it finds a difference, it can just be triggered and call maybe SageMaker or call like SNS, etc. and to call a function to get the job done. So that is like a last management and it's a service. Also, like a lot of his Kinesis features, they're service. Also, some of database, I would say a lot of this database that AWS offer their service, like OpenSearch, etc. They're kind of a service that you do not need to sit there and serve your model. But auto scaling is just one of the features. We called it service for like this EC2 instance. So you do not need to sit there and launch the instance where you see a high traffic, but it will auto scale itself. So hopefully it's clear.
So like service, and then the others just a function that's included in the service. Is that what you mean?
Yeah, you can understand in this way from a high level perspective.
Mm-hmm.
Yeah, but as I just mentioned, it's a typical solution architect question. You can definitely find the answer for the solution architect study.
Great. Another question is very high rated. So is the model trained every day? Can you tell us an example where you have to fall back to the previous model?
The fallback, you mean? Okay, so for model train every day, I can answer this first question for. So it really depends on what are the service. I do know there are different services they train every day, especially you get a lot of new data coming in. For example, like for the Google search, they definitely retrain every day or maybe hours. It's like there's a news coming out when there's no COVID as words before it appeared. So if you're not going to retrain your search system, your model knows nothing about this COVID word, oh my God, the search system will be terrible. So that's kind of how everything got retrained. Similarly, for a lot of this recommendation system, if something got popular, it will get retrained. So it really depends on the frequency of your machine learning service, your machine learning model. For example, for this millions ago, this visual search kind of model, like if the goods on your shelf is the same as a year ago, probably you do not need to retrain the model. But if you have some new goods, if you have a new kind of coffee coming in and your model knows nothing about it, oh my God, I don't think your model will detect something good. So that's why you need to, as a machine learning engineer, you need to decide whether you want to retrain every day, or it also depends on the success metrics. So you have this unit testing and also QA testing to say whether my model can still predict beyond some threshold.
And the second part of the question is, have you ever like launched something and then you need to fall back to the previous model? I guess it's also related to what you answered. Maybe after you launch, like you keep retrain it and you have some kind of matrix to detect, the model is not performing well, so maybe it needs to trigger a fallback. So have you encountered some situation like that?
I haven't myself for this new model, but for my experience, I did know, and also my colleagues would train some new model with new architecture. For example, if you're doing NLP, you have this new transformer architecture, which sounds super fancy compared with the traditional model. So we trained that and we tested and felt like, oh my God, the model doesn't work as well as previous model, which is not that fancy one. So there must be something wrong with this transformer, right? So that's why we don't deploy it. As for like the fallback, I don't think I have any experience for fallback, but we always do model versioning. So if you're working with any of these AWS services, we have this version 1, version 2. So it's always easy to fall back. And then you also have this green-blue deployment. So the green-blue deployment is kind of, you test it. So like maybe 90% of the traffic is still sending to like the old environment and 10% traffic is sending to this new environment. And you kind of test it within period. You kind of shifting the percentage to this new environment from the old environment if it's test good. So that's like kind of the continuous deployment kind of practice, but I haven't really kind of rolled back anything.
And there's another questions about storage, I think. So the audience say he or she have a torch model around 200 megabytes, say, and it was too big to deploy on Sega. And do you have any suggestions on how to solve the issues besides reducing the model size?
So what is the question again? It's like the model is too
big.
large.
Boy.
Yeah, I would say reduce model size would probably the industry practice. There are a lot of like those transfer learning method or kind of meta learning method that you can like learn a new model. So and you can or like kind of distill the lives of like the whole models. But I would say from what I know from my team is what they're doing is more distillations is doing, because when you're going to deploy the model, you also care about the inference, like the throughput is like how long does your model take to kind of inference the result, right? It's like if you have 100 layers of models compared to you have like 10 layers of models, the inference speed probably will be a little bit different if you have a lot of data coming in. So that's something I would say not reduce the model size, but it's kind of smart reduce it. It's not, you're not just go to cut your trees, but you're kind of learn new model, like using the teacher model to learn new model to see whether it can capture maybe 99% of the previous model performance. It clear? Yeah, just quick note. So what we're just doing is lab 0 here. But after you launch that, you can then after you launch that successfully, you can then go to the SageMaker notebooks. So you will see there will be a one instance in service. So you can click through that and you can open that MLOps lab tutor notebook. And that will include all the notebook for lab 1, lab 2. So you can click through that. There will be a lab inside of it. It's pretty slow. Yeah, so this can, so there will be lab 1, lab 2, 2A, 2B, 2C. Let me make it a little bit bigger. So for lab 1, basically it's kind of super simple, straightforward. If you have done any training before, so what you will need to do, you will need to still fill in some of the blanks there. I left some extra, like I say, extras 1, there's some blank you need to fill it in, but it's pretty straightforward. Let's say your URL is here and the row is also definable. Similarly, there's some exercise below, so you can, after you fill in the blank, you can then run this and it will deploy an endpoint. But make sure after you deploy the endpoint, you clean it up, delay that by calling this function, or you will get a bill like me, what I did, like several weeks ago, I got a small, tiny $1 bill. I didn't when I using that. So that's lab 1, and lab 2 is more automatic, and there's a stress test involved in to test like different traffic. If you have like 100 kind of traffic or 1,000 traffic or like 10,000 traffic, etc. So that's just an overview. Another thing I really want to discuss before we close our session, and we only have 5 more minutes, is like you need to delete your stack of CloudFormation. Okay, so here's my CloudFormation stack. You can see there are 8 stacks here even though we are just launching 1. Also, they are just substack of our main stack. So what you need to do to delete, you just need to click this women in data science 0325, and you just need to hit this delete function. It will help you delete everything that you created. So yeah, that's just something I want to say before we close up.
Someone asked where's the log, like where can they view the log of debug of the rollback in progress? I think you mentioned.
Yeah.
Oh,
Yeah, good question. Let me see. I remember there will be some, I remember it should be this event button. So it will show you what is a question. What is the error here of the status? It's like the status read. Let me see if I can find some sample example for you. Like I used to log everything that I made. I'll log out all the arrows. Oops, instructions. So for anyone who has question, has error, feel free to raise it here in the chat, and we can also solve together.
oh, I think Alex sent us a screenshot.
Oh, cool. Let me check that. Oh, there is a screenshot.
But it's just say it's a rollback complete, and then the status is cross.
Oh,
The status.
okay.
There's no reason for the status reason. Like
Yeah. I understand. So you need to scroll down. So there will be some other thing that I filled before this. So this is just a conclusion. Told you that rollback is complete. So just go down a little bit. So you can see a lot of things happening where we're kind of created that there must be something that gives you error. Maybe you have the securities problem, or maybe some like the bucket don't have the permissions. So you need to find the first kind of failures give you the error, and then you go to solve it. There will be some reasoning on this status reasons here.
someone also asked if we can pause the stack instead of just deleting it. So
Sorry about that.
So pause the stack instead of deleting it so that it stops the charging, but next time they can reactivate it.
That's a good question. I'm not quite sure about pausing it, whether I don't think CloudFormation will charge you. Well, maybe I was wrong. I'm not super good at about pricing for each different services. But I think if you're not hosting an endpoint, like a SageMaker endpoint, you won't get charged. That's my understanding of like this pipeline, because from last time, I only got charged from my SageMakers. So when running the lab one, I got charged, but I don't think this CloudFormation got charged, but maybe I was wrong. I kind of forgot of that. Let's see. So here is, you can always see your bills somewhere. Where are your bills? As you can see, I got charged by SageMaker and also S3. So I don't think anything else charged me. That's my understanding, but probably different account have different use cases. And I don't think, yeah, you can leave that in your account to see whether you got charged, because I don't think anything is kind of active function like a hosting an endpoint there. So I don't think you all got charged, but don't call me, maybe I was wrong.
Okay, just we said 1 minute, so the last question would be a follow-up of the for the questions that we talk about the memory. So the audience asking, based on your experience, what are the biggest model that can be acceptable to deploy on SageMaker? Do you know any?
Acceptable? You mean just acceptable? I would say probably defined by your own use case. It's like in problem formulation at the start, you will know what are the metric, what will be a success look like, right? It's like for this mini and long goal project, we are using like this mean average precisions. If this object get detected with a high mean average precision, we'll say, oh, it will be a good model. So that is our understanding, but it will be different for different use case. But for SageMaker, I'm not exactly sure. Maybe you can elaborate more for SageMaker's kind of understanding.
I think the previous question is about one of the audience that they have a very large model, like when they upload to the SageMaker, it's not enough memory, I guess, and they are asking if there's any limit or the biggest model that we can be upload to platform.
I'm not exactly sure, to be honest, for this hosting question of limit upload. But SageMaker probably have some documentation on their side. Yeah, I would say definitely here, SageMaker needs to do a better job in hosting. It's like so you can always reference to SageMaker deployment. Yeah, that's where I already go. As you can see, deploy model for inference. So whether there are some limitations, object model performance with scale, great containers. Yeah, I would say just go try to search it here. If not, you can always go to submit the feedback from the SageMaker GitHub. It's also like open source here. Submit a question. I'm not exactly familiar with what is like the limitation of this hosting, but it also depends on what kind of instance you use, right? Do instance have enough memory to host your model? If like your instance have like, for example, 64 gigabyte and your model is huge, then there are probably some problem there. So it really depends on a lot of different things, not only SageMaker itself.
Great. I think it's time for us to have a break. And thank you so much. Thank you, Rachel, to walk us through the whole process, how to do a basic case of end-to-end pipeline in CloudFormations. I think it's very easy to use and follow. And we just posted the link in on chat. Like if you feel free to reach out, Rachel, anytime. And thank you so much once again. Thank you so
much. Everyone, and thank you, Macy and Celine, for organizing. Thank you, everyone, for organizing here and having me here. And I will see you offline.
And let me share the screen. We have prepared. Before the break, we have prepared a music performance for all of you to relax a little bit, to enjoy, welcome the weekends, a very relaxing sections. So welcome Eric, who is gonna help us present. They give us some performance today.
Hello.
Okay. I think maybe I can stop the recordings. Do you want to be? Yeah, I'll just stop the recording first.
Sure. I mean, you can leave it if you want. I don't mind.
I would secretly record it for sure.
Okay, go for it. You do that.